This is geometry. Unit 6, we're going to write and graph equations for lines. So yesterday we talked about slope. And slope is rise over run. The equation for slope is y2 minus y1 over x2 minus x1. It's very important to have the y values on top, x values on bottom. When the slopes are the same slope, that means your two lines are going to be parallel to each other. When your two slopes are opposite reciprocals or negative reciprocals, your two lines are going to be perpendicular to each other. One way a linear equation can be written is called Slope-Intercept Form. So your equation is going to have a slope in it, and it's also going to have a y-intercept in it. Linear equations in this form can be written as y equals mx plus b. You would have learned about that in algebra, where the m is the slope, and b, look at your equation, the b value is the y-intercept. The m and the b are considered constants. They are numbers that aren't going to change in the problem. Where the x and the y are values along the line following the path of that same slope and that same y-intercept. The x and the y can change, but the slope stays the same. So we're going to come here and look at our graph. We're going to calculate our slope. We're going to calculate or look at our y-intercept and write our equation. So using from one point to another, it shows that we're going down 3. So we'll call that negative 3. And we're going over 1, 2, 3, 4, 5. So it's a rise over run of negative 3 over 5. Now, the way I wrote my 3 over 5, I put my negative in front of the fraction. Okay? In front of the fraction just implies that that negative can go on either one. So if we look at this from the other point of view, if we go from this point and go up 3, so a positive 3, but then we would be negative 5 moving over. So regardless of which point we go to, we're going to have a positive version and a negative portion to our fraction. So it doesn't matter which the negative goes on, but only one of the numbers gets it if it's sitting in front like that. The y-intercept. Take a look at your graph. Notice where it crosses the y-axis. The b value for your y-intercept is clearly going to be 3. So if you have a slope and you have a y-intercept, you're ready to write your equation as 3x, mx plus b. That is the equation that we're trying to write. So we know that our slope is negative 3/5, and our y-intercept is a positive 3. There should be an x inside there also. mx plus b. Now, what if we were given just 2 points? This could be our x1 and our y1, our x2 and our y2. for us to calculate the slope so that we can write the equation of the line, we need to know that it's y2 minus y1 over x2 minus x1. So our y2, the way that I've written it here, is negative 4, that's the y2, minus y1, which is negative 12. x2 is 6 minus x1 is 8. So this gives us a negative 16 over a negative 2, which reduces to positive 8. Now, before we even do that, you might even make a sketch. Positive 6, negative 4, positive 8, positive 12, just to give us an idea of what's happening for this equation. You see that our slope is going to be positive. It's increasing to the right. Increasing. And that's what we got. We got a positive number. This is very steep. It's nowhere close to horizontal. So that's why the number's kind of big. It's not a fraction like 1 over 2. Next, we're going to look for the y-intercept. We see that the y-intercept should be way below the 0. This is the point 6, negative 4. I'm going to go down 8 and over 1, down 8 and over 1, down 8 and over 1. I think I'm still going to go down 8 over 1, down 8 over 1. There's a lot of down 8s involved here. We got to get all the way over till the x value is 0. So for us to find the y-intercept, we're going to take y equals mx plus b. We're going to solve for the b. We know our y value. If you want to use this y value, doesn't matter which point you use, as long as it's on the line. We're going to use this y value. We calculated the 8 for the slope. Then I'm going to go to my x value that corresponds with the y that I used. My x value happens to also be 8. So we don't know what the b value is. That's what we're trying to solve for. We have one equation and we have one unknown. We can solve for the b. So this is 12, this is 64 plus b. For us to calculate and get the b by itself, we need to subtract the 64 to the other side of the equal sign. And what that's going to be is a positive 64 minus a 64. We cross those out because we're subtracting it to the other side. That just leaves me the b with the equal sign. We have 12 minus 64 should be negative 52. So we calculated our b value. We calculated our slope. We even drew a little graph to give us an idea, and we figured out that that was going to be pretty far down there, which negative 52 would fall off the edge of most graphs. So y equals mx plus b. Our slope we calculated was 8, and our y-intercept we calculated was a negative 52. Notice that our equation needs an x and a y. That's an equation. You're going to have your constant numbers for your slope and your y-intercept. Those aren't going to change for this problem. They're going to always be 8, negative 52. But the x and y, depending where you are along the path, that x and y changes. Now we're going to look at this point. We'll make another sketch so we understand geometrically what's happening. Negative 6, positive 7, might be right there. We need to figure out a parallel line through that point that is parallel to negative 5 with the slope of 3. So we go to negative 5 and we do a slope of 3 . So there's our given line. There's our point not on the line. And we want to know the equation of this dashed line. It obviously is going to have a positive slope because it's got to be parallel to this one. And it's going to have a y-intercept that's up here somewhere. Okay, how can we figure out some of those numbers? What's the slope of our given line?
3.
The given line, the slope is right in front of us. It's going to be 3. What's the slope of the line that we're trying to come up with? It's also going to be 3. If we're doing a parallel line, it's got to have the same slope we said. Parallel has the same slope. The point that this goes through, of course, is negative 6, comma 7. That's going to be our x and our y. So when we do our y equals mx plus b, I'm going to plug my y value in, my 7 in for the y. My slope we said was 3. My x value is negative 6. That's going to give us a negative 18 plus b. So using our algebra skills, I look at where the b is located, and I want to move this negative 18 away. So I need to do the opposite of the negative 18. So that means I'm going to add 18 to both sides. That would make the 18 go away. 25 equals the b. Which, looking up here at our graph, we see that this is increasing well above the x-axis. So it might be reasonable to believe that it's going to be 25. Y equals 3x plus 25. That would be our equation of the line parallel to our given one. Now we're going to do the same thing, but we're going to do it perpendicular. So let's make a quick little sketch of what this might look like. We have a point at 4, negative 12. Our line is at negative 17. That would be down even further. And it goes down 4 and over 3. Down 4 and over 3. So it's going to be something like that. So to be perpendicular, we need the equation of the line that's coming this way. That looks about perpendicular. So we're expecting a slope that is positive, and we're expecting a y-intercept that's going to be down here, somewhat close to the 17 apparently. I don't quite know if it's below it or above it, but it's somewhere near that 17-ish area. So the given slope is negative 4/3. So what's our perpendicular slope going to be? If it's perpendicular, we're going to flip the fraction and change the sign. So now it's going to be a positive 3/4. And the point, of course, this is going through is 4, negative 12. That's going to be our x and our y. So just like before, we're going to take y equals mx plus b, plug in our negative 12. Our slope is supposed to be perpendicular to the given, so it's going to be 3/4. Our x value is 4. And we don't know what our b value is. We have to solve for something. We have one unknown for this one equation. So now how do I calculate 3/4 times 4? We can place the 4/1. Some people like to visually see that so they can cross the top to say 12. 12 divided by 4. 12 divided by 4 is 3. Some people also think about crossing the 4's out, and you're left with 3. Either way you want to think about that. So we have negative 12 equals 3 plus b. We're going to subtract, and we got our b value of negative 15. So y equals 3/4 x minus 15. That is the equation of the line. It should be positive, just the way we sketched it. It should cross well below the x-axis, somewhere down near 17, and that's what it did. All right, last one. We're going to graph this equation. They're suggesting that we convert this equation into slope-intercept form. So we're going to take our 2x minus 3y equals negative 12 and subtract the 2x to the other side of the equation. That leaves me with the negative 3y on the left side of the equal sign. These are unlike terms, so I cannot collect them. I cannot call it negative 14. And then I'm going to go through and divide everything by the coefficient of the y, by the negative 3. Two negatives make a positive. So we're not surprised. Our slope is supposed to be a positive number. So it's 2/3 x. If the x had to be on a number, the x is actually on the 2. But we usually write our fraction. That's awful now, and I can't see anything. We write our fraction in front of the x. And then when you divide, you get 4, and 2 negatives make a positive 4. So we're going to come over here and try to graph this out. So I'm going to go to positive 4. and do up 2 over 3. Now watch my scale. My scale is kind of funny. So up 2 is really one line. Over 3 is going to be a line and a half. Up 2 and over 3. Down 2 and backwards 3. So I'm doing the slope in a backwards fashion. Down 2, negative, negative. And there's my line. It's great if you could write the equation of your line on your graph. Would love for you to have graph paper to do these.